Alright, we've talked about slope fields in the past, and I want to look at how we want to try to solve potential differential equations. And really we have two possibilities. One is to say verify that we have a solution, and the other one is to determine a solution. So the first thing we have here is verify that sine of x is a solution to this differential equation. Well, y equals sine of x. Y equals sine of x, that means that y prime would be its derivative, which is cosine of x. That means y double prime would be the derivative of cosine, which is sine of x. Well, now I have y double prime, which is negative sine x, plus y, which is sine of x. We want to confirm that equals 0. Well, yes, negative sine x plus sine of x equals 0. That means 0 equals 0. That's a true statement. That means that it is a solution. That's how you verify. Same with this one. Y prime equals 4y when y equals 3 to the 4x. That means y prime would be, by chain rule, 4e to the 4x. So if I plug that in, that means this 4e to the 4x, is that the same as 4 times y, which is e to the 4x? Absolutely it does. Those are the same thing, so I have verification that those are the same. Now, the other possibility is to determine. And our steps are as follows. We need to get both dy and y on the same side, dx and x on the same side of the equation. So to do that, the easiest way in most of these is first you're going to need to multiply by dx on both sides to get that dx out of the bottom, and then whatever we need to do to get y to the other side, which in this case would be multiplying by y on both sides. So I end up getting, if those cancel out, I get y times dy equals x times dx. Now where do we see this most often? We've been seeing these when we do integrals, and that's what we need to do. We need to take an integral of both sides to get rid of these differentials. So that means the integral of y dy is going to be 1/2 y squared, and the integral of x dx is 1/2 x squared. Technically, if I take an integral, I need a plus c on both sides. However, a constant is the same. Well, it's not the same, but it's just a number, so I only need it on one side. If I had it over here, I could subtract it over with the constant over there and just make a new constant. This one here is what we call a general solution. And really all you need is something with y, x, and a constant. You can see lots of different possibilities for this solution, though. They could have made it, if I multiply everything by 2, it would be y squared equals x squared plus 2 times the constant. It's still a constant. That would be another way to do it. They could maybe get the constant by itself. Y squared minus x squared equals a constant. They could even try where from here you get the y by itself. So y would equal plus or minus the square root of x squared plus a constant. There's lots of different ways to make a general solution. Mainly it's just being able to manipulate your equation to make it match what they would give you on a multiple choice. But this is what I'm mainly looking for right there. Here's another example of one. In this one, it doesn't look like we have anything to work with. However, y prime just means dy dx. Everything else stays the exact same. Now, again, same thing. We need to try to make it so dx is on one side, dy is on the other. So first, let's get everything else out of there. Let's get this x squared to the other side. So I'll have 5y dy dx is equal to a negative x squared. From here, how do I get, I have y and dy together. I need to get the dx out of there. You multiply both sides by dx. So I have negative x squared dx. Now I have my y's and dy's together, my x's and dx's together, so now I can take my integral of both sides. When I do that, the integral of 5y is going to be 5/2 y squared. And over here I'll have negative 1/3 x cubed, and then plus c at the end. Usually this is probably not how it's going to be as a result. What I would say probably is they would have c by itself. So 1/3 x cubed plus 5/2 y squared is equal to a constant, just adding 1/3 x cubed to both sides. And then what they might do is they might try to get rid of these denominators. And to do that, they would multiply the whole thing by 3 to get rid of this denominator, and by 2 to get rid of this denominator. So you would end up with 2x cubed plus 15y squared is equal to, it's still just a number, it's equal to some constant. This is probably what you would see. I'm worried about, can you get to this step right here?